Deep beneath the waves, east of Japan, lies a volcano so vast its existence challenges our understanding of Earth. This is Tamu Massif, once declared the largest volcano on the planet. But what secrets might it hide, and could life exist within its molten stone? Tamu Massif sits nearly 2,000 meters below sea level and stretches over 500,000 square kilometers across the Shaski Rise Plateau. When first studied in the early 2010s, scientists claimed it was the largest single shield volcano ever discovered. Its slopes are incredibly gentle, so gradual that, if you were walking on it, you might struggle to tell uphill from downhill. But science evolves. More recent research has challenged the idea that Tamu Massif is a classic shield volcano. Magnetic lineations across its surface hint that instead it may be built like a mid-ocean ridge feature, gradually inflated by spreading crust beneath. Rather than a single eruption spilling lava outward, it may have formed through a slow, sheet-like uplift, a sheet cake rather than a layered stack. If Tamu Massif is truly a single, coherent volcanic structure, its footprint rivals the size of New Mexico, dwarfing even Earth's most famous active volcanoes. More importantly, it may teach us new principles of how underwater volcanic plateaus form, rewriting textbooks on geodynamics and oceanic crust formation. But geology is just half the story. What about life? In the darkness of Earth's hidden depths, microbial ecosystems flourish, often powered not by sunlight, but by chemistry. Could the underbelly of this giant volcano host living beings adapted to extreme heat, pressure, and chemical flux? We've already discovered life thriving around hydrothermal vents, deep-sea volcanoes, and cold seeps, organisms that live off chemical energy by oxidizing sulfide, methane, or hydrogen. These extremophils are proof that life doesn't always depend on sunlight. It adapts. Inside a volcano like Tamu Massif, temperatures, pressures, and chemical gradients combine. Magma chambers may feed cracks, circulating hot fluids through crustal fractures. In those cracks, temperature shifts could foster zones where microbes survive. Mineral veins carrying hydrogen, sulfur, iron, and trace metals might offer the raw ingredients for chemosynthetic life. Imagine thermophilic microbes lining narrow fissures, clinging to mineral surfaces, extracting energy from chemical disequilibria. They may resemble archaea or bacteria already known from hydrothermal vents, but adapted to hotter, more static environments. But life inside volcanic rock faces severe challenges: extreme heat, toxic gases, limited fluid flow, and isolation. Much of the crust is sterile basalt, and cracks may be sealed by minerals. Only very specialized life could persist in isolated microneaks. So far, direct sampling inside Tamu Massif is nearly impossible. Geologists drill cores to sample basalt, look for trace carbon, isotopic anomalies, and microscopic biosignatures. On other seafloor volcanic regions, microbes have been found in basalt boreholes tens to hundreds of meters deep. Let's imagine one possible ecosystem. Hot fluids percolate upward, carrying hydrogen, methane, or reduced metals. Microbes attach to walls of cracks and fractures, oxidizing those chemicals. Some may form biofilms, aiding mineral alteration or producing gases. Others lie dormant until pulses of fluid supply energy. Discovering life in such settings would have profound implications for astrobiology. If microbes can thrive in rock deep inside a volcano, maybe similar life exists beneath Europa, Enceladus, or Mars, wherever heat and chemistry meet. It expands the habitable zone concept beyond surface water and temperate climates. What it would take to test for life inside Tamu Massif? We'd need advanced drilling submersibles, micro-sampling robots, deep ocean ROVs capable of penetrating rock crust, and ultra-clean biosampling. Collaborations between geophysicists, microbiologists, and engineers are the frontier. We must temper excitement with humility. The evidence today is speculative. Life inside remains hypothetical. But the possibility is real and waiting to be tested. Tamu Massif reminds us Earth hides more than it reveals. A volcano so vast, so ancient, that we may not yet know its deepest secrets. If life can exist in the cracks of magma-cooled rock, then the definition of where life belongs must expand. Join us as we push deeper into Earth's underworld, not only to understand geology, but to ask the most profound question: where else is life waiting? If you enjoyed this journey beneath the waves, hit like, subscribe, and ring the bell so you don't miss future deep Earth explorations. Let me know in the comments. Would you dive into the silent heart of a volcano if you could? Thanks for watching, and until next time, stay curious.